Dear students, today we are going to discuss few things regarding runtime polymorphism. Polymorphism in C++ can be divided into two types: compile time, early binding, or runtime or late binding. Compile time is implemented using function overloading and operator overloading. Runtime polymorphism is implemented using virtual functions. Polymorphism is classified into two branches: compile time polymorphism or early binding, or the other name is static binding. Runtime polymorphism is also called as late binding or dynamic binding. What is binding? For every function call, compiler binds or links the call to one function definition. This linking can happen at two different times: at the time of compiling the program or at the time of execution. Compile time polymorphism, function overloading is an example of compile time polymorphism. This decision of binding among several functions is taken by considering the formal arguments of the function, their data type, and their sequence. So this is an example of compile time polymorphism. The function my function is overloaded by accepting two arguments, integer I or character C. Runtime polymorphism. In late binding, call to a function is resolved at runtime. The compiler determines the type of object at execution time and then binds the function call to a function definition. Late binding is also called as dynamic binding or runtime binding. The virtual functions are example of late binding in C++. Runtime polymorphism is also achieved using pointers. Pointer behavior in polymorphism. A base class pointer variable can hold the address of the derived class object, but it can access only members of the base class. So this is an example. So this is the base class which has a function called show, and a derived class which also has a function called show. So this is the base class pointer. So the base class OB is an object of type derived, and the pointer holds the address of OB, that is the derived class object. Though it holds the address of the object, when the pointer calls a show function, it calls the base class function. So you can see that even the pointer holds the address of the derived class object, it has called the base version of show method. The problem is, even a base class pointer holds the address of the derived class object, it can access only members of base class, because the base class pointer variable does not have any idea about the structure of the derived class. A base class can't have any idea about what derived class has added to it. So this is how we include the keyword called virtual. So base class and derived class both have the function called show, and this base class function is included with the keyword virtual, making the function as a virtual function. So this time the base class pointer holds the address of the derived class object, so it is going to call the derived class object. How virtual function works. Base class pointer can point to derived class object. In this case, using base class pointer, if we call some function which is in both classes, then base class function is invoked. But if we want to invoke the derived class function using the base class pointer, it can be achieved by defining the function as a virtual function in base class. This is how the virtual functions support the runtime polymorphism. Virtual function is a member function that is declared as virtual within the base class and redefined by a derived class. To create virtual function, precede the base version of the function declaration with the keyword virtual. When a class containing virtual function is inherited, the derived class can redefine, that is, override the virtual function to suit its own unique needs. The method name and type signature should be same for both base and derived class version of the function. So now what is exactly the difference between method overloading and overriding? Overloading occurs when two or more methods in one class have the same method but different parameters, that is the signature. Overriding means having two methods with the same method name and parameters, and one of the method is in the parent class and the other in the child class. Call to an overloaded method is resolved at compile time, while call to an overridden method is resolved at the runtime depending upon the type of the object. Thank you.